Welcome to the project demonstration of solar power grid-tie inverter. So in this project we are going to using of solar panel to charge our battery, and after the battery is fully charged, so the DC voltage given as main input to this grid-tie inverter circuitry. So here the 12 volts DC will be converted initially to the 12 volts AC, and then after the 12 volts AC will be step up to the 230 volts AC with 60 watts of power. So this is a step up transformer, and this particular IC will generate the 50 Hz pulses, and that pulses will given as input to the trigger pulses to these two MOSFETs, and these MOSFETs will give the 12 volts pulses with same current, because we are providing 12 volts 1 amp, and that 12 volts 1 amp pulses will given as pulse input to this step up transformer, and which will step up the 12 volts 50 Hz frequency to 230 volts 50 Hz frequency. So that given output to the load section. So we can drive the loads up to 60 watts of power maximum. So we are using the ratings of 12 volts 5 watt solar panel. So if you want to charge this 12 volt 1 amp battery with help of solar panel, then we need to disconnect the T here, and we need to connect S solar panel. Okay, so now the system is charging with help of solar panel. So we can see the light is slightly glowing with help of this lighting. So if we place this under the sunlight, we will get maximum voltage which is sufficient to charge our battery. So this battery pack consists of 3 4 volt 1 amp batteries are connected in series, so we will get 12 volt 1 amp directly. And next, coming to this charging circuit, so we are providing inputs from the solar panel, though we can see 4 diodes. The 4 diodes purpose is bridge rectifier, which will convert AC to DC. But now when we connect to the solar panel here, this bridge rectifier won't work. Just they'll work as a short circuit. From that to the capacitor, and capacitor through these 2 diodes again. The purpose of these 2 diodes is it's useful for the reverse current protection purpose. Whenever the battery is fully charged, means when it is high potential and the source is low potential, then these 2 diodes will oppose the current flow from the battery to the solar panel, right? And LED indication will show us the status of the charging circuit. So if you want to charge a battery through the transformer whenever there is no sunlight during the night timings, just connect the T at this section, and next give the 230 volts input to the socket. So then you can see the LED indication, and it will take 8 hours maximum to be fully charged, either through the transformer or through the solar panel. So in this, when we connect the transformer here, these 4 diodes will use it to convert the 12 volts AC to 12 volts pulsating DC, and then the pulses will be removed from this capacitor, and after the capacitor will get the pure DC for the battery charging section, right? So in order to utilize this one, there is a main on off switch. So then there are 2 LED indications here. We can see that the grid-tie inverter main purpose is in order to identify the maximum load, because we set the load for the 50 to 60 watts. When we connect the heavy load here, the grid-tie inverter will on this another LED indication and off the load in order to protect the circuitry. So that is the main purpose of this grid-tie inverter.